All right. So looking at these, this would have been the setup for each of those. Why did I put grams on the bottom of each of these? Because I'm trying to cancel grams. So going through here, this should give me moles. Now I'm looking here, I have 4 sig figs. I set my molar masses up so that I didn't have to worry about them in the sig fig calculation. All right. So my answer is going to be in 4 sig figs. So I have 1.574. All right. And that's going to be mole of Cu. All right. For this one, for sodium chloride, again, I got rid of grams, and I'm getting mole of Cu. I mean, mole of NaCl, so I have 7.711. And hopefully I copied that down right off of my calculator. And then here, yes.
For the second one, is it not 1.7?
Yeah. Okay, yeah, I have a little mark. Okay. I must have made a little mark on it, and it, when I printed it, it showed it as a 7. All right. So we get that. Now, that's all for moles. What if I wanted to know atoms of copper in this one? Just for what would I need to do to that moles of copper to get to atoms of copper? Yeah. So because for every 1 mole, I have Avogadro's number of particles, I would just multiply by Avogadro's number in that case. Now, if I was given in atoms and going the other way, then I would divide by Avogadro's number. So here, if I did it, I'd get 9.479. 9.479 times 10 to the 23rd atoms of copper. All right. So now, the reason why I was showing you that is because now I'm starting you with 1.24 times 10 to the 23rd particles of each. So because this is an element by itself, I'm looking at atoms of this. I'm looking at formula units of this. And then I'm looking at molecules of this. No. We're starting with 1.24 times 10 to the 23rd, and that should be 24th. Yeah, 24th. So do it times 10 to the 24th particles. And so real quick, we're going from particles to mole to mass. Give me just a second so I can. All right. So looking at this, my first step is to get rid of whatever particles I'm in and get to moles. So my relationship is that I have 1 mole of 6.022 times 10 to the 23rd particles. And that allows me to get rid of the particles and go to moles. And now once I'm in moles, I can go from moles to mass using molar mass. So for every 1 mole of copper, I have 63.55 grams. Then it allows me to solve it. Here, I need to get rid of formula units. So for every 1 mole, there's 6.022 times 10 to the 23rd formula units, and that gets rid of formula units. And then for every 1 mole, looking back on my previous page, I had 58.44 grams. Same thing for every 1 mole, I have 6.022 times 10 to the 23rd molecules. That should have been molecule. So I get rid of molecule, and then grams. All right, check your answers. All right, any questions?
Yeah.
Yes.
I don't get that when I plug it into the calculator.
All right, so a couple of things that I want to make sure of. All right, when you're entering into the calculator, if you're entering this in, make sure you're telling the calculator that that's all one thing and that's all one thing. So there's 2 different ways you can enter it in to get that. So what I would do is I would put them in parentheses and just do this divided by this and get that number, which should be right around 2. And then take that 2, that number, and multiply by that. All right. So whenever I do, so check this for me. If I do 1.24 to the 24th divided by 6.022 to the 23rd, I get 2.059, and then I can multiply by each of the molar masses. All right, that's a key thing. Whenever we're doing scientific notation, make sure the calculator realizes that's scientific notation and that we're not multiplying exponent every time, because it will throw you off. All right. So that's kind of the gist of what we're doing today. We have to be able to go both directions using these. We have to be able to go from particles back to mass, mass to particles, things like that, and stopping anywhere along the way. So we can do mass mole calculations, mole mass calculations. We can do mole particle calculations, particle mole calculations, or we could go all the way from a volume to particles. All right, let me look because I was having some trouble with it earlier today. You're welcome. All right. This sheet is going to end up being due Thursday, but there's some stuff that I want to make sure it's only one. I'm going to make sure you kind of understand some of the questions, how they're being asked, and what we're looking at. So, all right. So, looking on the front side of this sheet, the goal of the front side is to get us to understand the relationship of everything to 1 mole. So, molar mass of 10, number 2, all we need to really know on this is that the symbol for 10 is SN, and then we look it up and we just pull it straight off the periodic table. I'm going to ask that you pull every mass off to 2 decimal places, just for consistency's sake. All right. Now, looking at number 3, it says, what is the mass of 6.02 times 10 to the 23rd atoms of arsenic? What does 6.02 times 10 to the 23rd atoms represent? 1 mole. So how many, what is the mass of 1 mole of arsenic? 74.92. All right. Looking down, it says, is 1 mole of zinc the same as 1 atom of zinc? No. How many atoms is it? Yeah. So, no. 1 mole of zinc equals that. All right. And then looking at the bottom one, how many atoms are there in 1 mole of atoms? 6.022 times 10 to the 23rd, Avogadro's number. All right. So though a lot of these questions are going to kind of ask the same thing, and it's just that relationship between mass and mole and particles. All right. So they're phrasing them in weird ways. All right. Now, looking on the back side, we know how to calculate molar mass based off of a chemical formula. So, for example, arsenic, I look it up on the board. All right. For this one, I could calculate this one because I have 2 hydrogens at 1.01, which means I have 2.02. I have 1 carbon at 12.01. And then I have 2 oxygens and then I would just add those together. And that's going to give me my molar mass there. So we should be able to calculate molar mass based off of a formula. All right. Now, what we need to figure out is how do we solve for this? How do we solve for moles? How do we solve for mass based off of what we're given? So in this one, I'm given 3.5 moles. All right. If I'm given 3.5 moles, how would I find out how many particles or atoms of arsenic I have? Yeah, so I'm going to take my 3.5 mole 6.022 times 10 to the 23rd.
Does it matter, like decimal places?
So on this one, because this is only 2 sig figs, my answer here is only going to be 2 sig figs. All right. So I'd figure that out. And then now I also have to find out how much mass I have. So in order to go from moles to mass, what am I going to use? The molar mass. So 3.5 mole. So 74.92 grams for every 1 mole. And that's going to give me that one.
And 2 sig figs, right?
Yeah. Yeah. All right. Now, looking at this one, based off the information I have, can I solve for particles first? No. No, I can't. Not having a mass. If having a mass and a molar mass, I can't solve for this yet. I can solve for moles of particles, are just moles. So I can go from here to here, because I can take my 138 grams, and then I can use my molar mass. So for every 1 mole, I have grams, and then I can solve there. Now, in this one, I have molecules, and I can find out my molar mass. I don't need anything but the formula to find out molar mass. But can I go from particles directly to mass? No. I can only go from particles to moles. So 1.2 times 10 to the 24th. And so I'm going to use Avogadro's number, 6.022 times 10 to the 23rd is 1 mole. And it should give you right around 2.0 moles. And then now that we have moles, we can solve for this, but we have to get this first. All right. So this sheet is going to be due on Thursday. I've also opened up Active for Chapter 6. If your computer is giving you trouble with Active, I might have to check and see if they didn't block it. They do that sometimes. And we'll see to make sure. So you have the remainder of the time to work on this sheet, and I'm going to play with Active and see what's going on with that.